So we've now completed our discussion of the nuts and bolts and the structure and functionality of the sequential streams portion of the streams framework. And so you should have a very good understanding now of different types of aggregate operations, intermediate operations, terminal operations. You should have a good understanding of things like splitterators and how they're used to break stuff up into chunks. You should also have an understanding of collectors that are used to take the chunks that have been processed and weave them back together into a final reduced result. And now what we're going to do is we're going to take a look at an extended case study, which is the SearchStreamGang case study. And we're going to start in this lesson by explaining the design of this program, which, as always, you can find at my GitHub repository at the link at the bottom of the slide. And this particular program is interesting for a whole bunch of different reasons. It's interesting because it's going to do a lot more than what we did with the simple search stream program. Simple search stream program just illustrated a few fundamental aggregate operations, collect and map and filter. So we're going to look at more stuff than just that in this example. And it's also going to give us a chance to talk about different performance characteristics. So as you'll see, we're going to have a whole bunch of different ways to implement the SearchStreamGang program implementation strategies, ranging from just good old loops, which is what we'll look at first, to sequential streams, which we'll look at next. That'll be the bulk of this discussion. And then once we start diving deeper into other parts of the Java parallelism frameworks, like parallel streams and completable futures and reactive streams and so on, we'll come back and compare and contrast the implementations first from sort of an apples to apples comparison in terms of how do the different mechanisms look to get the same consequences, that get the same output. And then we'll also explore the performance differences. And as you'll see, there's wild performance differences as you go to the more advanced parallelism mechanisms, where you get great speed ups with very little change to the code, which is kind of the whole point of all this. But before we get to that, let's first give an overview of what the program does at a high level. And I think that's always very useful when you're starting to learn about some program. It's good to kind of get the big picture view. In fact, I'm going to be releasing a series of video blogs or vlogs in the next week or so, talking about how to teach online courses. And one of the key themes that will come up as we get further into those vlogs is trying to demonstrate programs from multiple perspectives. So don't just look at the source code, but also look at kind of the design, try to look at the visualization of the behavior, try to give people different perspectives on what's going on, because source code, as important as it is only one way to understand what something is doing. And in fact, as your systems get more complicated, as your programs get larger and more intricate, you really have to think about more than just the code, because you get lost in the trees and miss the forest, as it were. Now, there's actually yet another program called the SearchTaskGang program, which you can find in my GitHub repository, that was kind of the original basis for what SearchStreamGang became. And SearchTaskGang uses object-oriented programming, not functional programming. And so that basically, that SearchTaskGang showcased the Java executor framework using tasks that were embarrassingly parallel. So if you are ever interested in learning about how to do the executor framework, which I will cover in my companion class taught in the spring, which is the course on concurrent object-oriented programming, you'll learn about the executor and the executor service and the executor completion service and the fork join pool and so on and so forth. Those are other ways, more object-oriented ways of doing embarrassingly parallel programming. We're going to focus here on using functional programming and different mechanisms that are part of the modern Java ecosystem in order to do that. So SearchStreamGang is a more powerful version of the simple search stream program that adds a whole bunch of new cool things. And of course, was also going to look in more interesting text for more interesting phrases than the simple search stream program did. In particular, SearchStreamGang is going to be used to find phrases, famous quotes from the Bard in the works of William Shakespeare. And I'm not quite sure why I always use this as my go-to example of embarrassingly parallel programs, but I'm a big William Shakespeare fan, so you'll just have to bear with me. You can actually go to MIT and get access to the complete works of Shakespeare. And if you do so, you can do what I did with this program, put them into a machine-readable form that can be searched using a program like we're using here in order to find where the quotes occur. Here's a very simple example. You can search for a phrase like brevity is the soul of wit, and this program will tell you what play and what basically character index number into the play that phrase occurred. So if you've ever wondered, which phrases occurred in which plays of Shakespeare, this is your way to find that out very quickly. You can also search for complex phrases that match across multiple lines. So of course, there's lots of famous phrases and things that Shakespeare said. Here's one that typically takes more than one line in the play. What's in a name? That which we call a rose by any other name would smell as sweet. And of course, I believe that's from Romeo and Juliet, as you can see in the rest of the text down here. And so that's actually a multi-line phrase. And so we're going to use very powerful regular expressions that can search across lines, which is actually itself a whole cool topic that you may benefit from knowing about at some later point in your career. The other thing we do with this framework, with this SearchStreamGang case study, is we allow apples to apples comparisons between a whole slew of different Java parallelism strategies. And this, I think, is really the true value of this particular case study and why we're going to look at it in the way we do. Because it allows us to be able to compare sequential loops with sequential streams, and then with parallel streams and different variants of parallel streams, with the fork join pool, with completable futures, with reactive streams, things like RxJava and the Project Reactor toolkit and so on. And all of these different approaches are all very different in the way that you implement the functionality. But what's cool about this is you can really go and look at the code and see very specifically where they differ, how they compare, how they contrast. So you can think of this almost like a Rosetta Stone that allows you to see the differences very vividly and easily comparable between the different ways of doing parallel processing in Java. And of course, the other thing that's fun is you can see the differences in performance. So your mileage may vary, as we always say, because depending on the number of cores you have and the amount of memory you have and the type of processors you have and the JDK that you're using and so on, you'll get slightly different performance. But in general, the trends are there. And the most important trend is that moving from sequential to parallel is a cinch especially with parallel streams, and the performance speedups are vast. They're really, really powerful. We're going to cover the sequential stream stuff first, and then we'll go into the parallel stream stuff starting next week, probably. What's cool about this way of doing things is that the transition to go from sequential to parallel streams is absolutely minuscule. In many of the cases, it's literally as simple as changing stream to parallel stream, and boom, you get this massive speed up. For example, if you look at these results, the sequential version took about 1960 milliseconds to do the processing of the works of Shakespeare. In contrast, the parallel versions took much less time. In fact, it's basically a super linear speed up, and I'll explain why a little bit later. Okay, so let's start by talking about how we apply sequential streams to the SearchStreamGang program. We're going to have a bunch of classes starting with search with sequential streams, and this is going to extend some framework superclasses that are part of the SearchStreamGang case study and the StreamGang framework. And then we're going to go ahead and override a couple of hook methods. Those are basically abstract methods that are defined in the superclass. And then we're going to define the particular characteristics for doing the processing with these different implementation strategies from Java and modern Java. The two key methods that we care about are process stream and process input. Those are the abstract methods that are defined in the superclass, and they're overridden in the subclasses, and they do interesting things. The sequential version, as you'll see, is very simple. It goes ahead and basically gets the work of Shakespeare as a list and converts it into a stream of the works of Shakespeare. And then for each work of Shakespeare, it goes ahead and calls this helper method called process input. And the process input method then goes ahead and searches for phrases in each work of Shakespeare, all sequentially. And this is a little bit reminiscent of the simple search stream program we looked at before. It's just that we only had one file for that program, and now we have many files, one for each work of Shakespeare. And we also were looking for words in the simple search stream program, whereas now in the SearchStreamGang case study, we're searching for phrases. So that, of course, is going to motivate the need for things like regular expression matching and very powerful pattern matching. Of course, we're also going to talk about the various aggregate operations, starting with the simple ones we've already covered, like stream, map, collect, filter, and so on, and then building up to the more interesting stuff later as we explore further into the example. The process stream method is really the entry point into the framework, and what it's going to do in this implementation is it's going to use a sequential stream to search a list of input strings in a single thread of control. And each input string will contain a work of Shakespeare, like the text for Hamlet, the text for Macbeth, the text for Romeo and Juliet, the text for Julius Caesar, and so on and so forth. And what you get back from the process stream method, as we'll see as we get into the details in a bit more, is a list of lists of search results. Some of those search results could be empty. For example, if you search for to thine own self be true in Romeo and Juliet, you won't find it because it's not in there. Whereas if you look for it in Hamlet, you'll find a match because it is in Hamlet. And we'll talk later about how to deal with lists of stuff using a very cool method, an aggregate operation called flat map. The other method that's important here is process input. This is kind of a subservient method to process stream. It's called in the context of process stream. And it uses a sequential stream to search a given input string, in other words, a given work of Shakespeare, to locate all the occurrences of the list of phrases we're trying to match. And this, again, all takes place in a single thread because this is the sequential version. The process input method, which is kind of a subroutine, if you will, returns a list of search results, which indicates wherever the phrase matched in that input string. And it could be empty because there could be no matches. So that's the end of the overview of this program. Now, again, we're going to be looking at code here soon, starting first with object-oriented code and then later with Java Streams, functional code. But I think it's helpful, again, to have that big picture view of what this program is trying to do so you're in a better position to understand the details as we start to walk through them in just a moment.